Hey guys, in this tutorial we are moving on from the conversation of what a confidence interval is and like how to interpret margin of error, how to interpret interval versus level, and now we're actually going to figure out how to construct an interval. So it gets a little mathy, which is good for those of you who love to do calculations. And in this section we're only focusing on proportions, so we're not even going to worry about whether it's a proportion or a mean. We're not there yet, so everything's going to be a proportion. I was listening to my video on the last skinny explanation, and I sound so bossy, so I'm going to try to be like nice and sweet, and you gotta let me know if I sound too bossy. So let's start with number 1. It says in statistics, what is meant by a sample proportion p hat? So we first got to make sure we even know what the heck a p hat is. So let's begin. It's a fraction, and it's usually, let's see here, it's usually expressed as a decimal or a percent. That's kind of how you know. And it's a fraction of individuals in a sample. So it's not the population, it's just a sample, like a little group of individuals that you're talking to. That exhibits some kind of characteristic. I can't even spell exhibit, y'all. Exhibit. Some characteristic. So let's make sure we know what in fact a p hat even is. And it's wearing a hat, so we're making a prediction. It's coming from a sample, it's not coming from the population. Now let's talk about the mean and the standard deviation of p hat. So we need some formulas, and I need us to get in the habit of using correct symbols. So let's see what that symbol looks like for mean. I think we know that mean is mu, right? But it's the mean of p hat, so we're going to make a little subscript right there. And the mean is always whatever p is, so they're going to give us p in the problem. So that's easy peasy, right? And then on the flip side, the standard deviation of the sampling distribution for p hat, that's going to require us to calculate something. So the word problems are going to give us p, but then, so that's going to be our mean. That's going to be the center of the normal distribution. But then we have to crunch a few numbers, and hopefully this looks a little familiar. To calculate the standard deviation of p hat, the sampling distribution, you're going to take that value of p, you're going to multiply it by its complement, which is 1 minus p. And you're going to divide all of that by the sample size. And what we got to really make sure, let me make sure that square root actually wraps around the whole fraction. And this is the standard deviation of the statistic. So this is actually how we calculate. So I'm going to actually make a note of that. And you might want to star this. This is the standard deviation of the statistic, not of the parameter. So it's of our sample, and it's p hat. It's the standard deviation of p hat, okay? So we're going to use these formulas over and over. You'll get to the point where you just about them. Sorry, guys. How does this standard deviation differ to the standard error? So standard deviation and standard error are talking about the error in our calculations, right? So let's get down to business and talk about how they are different. So let's see here. Standard error uses p hat. You know what? I can't type this, so I'm just going to write p hat to estimate the value of p. Now, there's a difference between p hat and p. We're using p hat to estimate the true proportion of the population in the standard deviation formula. So standard error is just taking the proportion from the sample to estimate the standard deviation for the populations. Standard error is just an estimation from your sample. Okay? Now let's talk about describing the sampling distribution of a sample proportion. So now, when you have to describe any distribution, remember we use SOCs, so we have to talk about shape, we have to talk about center and spread, and then we always bring in if there are outliers, correct? So let's figure out what the shape is going to actually be for our p hat sampling distribution. So let's see here. Let's talk about shape. We want it to be normal if the following is satisfied. I talked about this on our last tutorial. We always want the shape to be normal, right? And it required a calculation, and that calculation was the sample size times p. So we want it to be n times p has to be at least 10, and n times 1 minus p has to be at least 10. Let's talk about center. The center is going to be just at p. That's going to be given. This one's always given to us, which is fabulous. No calculations there. And then the spread, we're going to calculate the standard deviation, which I just gave to you, but we first must check. So first, check independence. Remember, and that was 10 times n has to be less than the population. Or it just has to make sense that the outcomes have nothing to do with one another. So you first have to check independence, and if that works, then you can do your standard deviation of p hat, which, remember, from above is the square root of p times 1 minus p over n. So all of this is kind of coming together from our discussion in 8.1. We have a few more problems or definitions to look at. In number 3, I discussed a little bit what standard error is. It is error, but it's just an estimation from the sample. So let's see here. We really got to wrap our brains around this. So let's be mindful of the fact that the standard error, let's see here, estimates, let's get this right, it estimates the standard deviation of a sampling distribution by using sample data. Sample data in the calculation. So it's just an estimation of the standard deviation, because a lot of times it's difficult to calculate the real standard deviation of the population, so we take sample data to calculate it. Let's see here, number 8. Okay, so here's the meat of, fast forward, I don't know why I said 8. We gotta look at number 6. In general, what is meant by the standard error of a statistic? So in general, it means that the standard deviation for the sampling distribution of, it's talking about the standard deviation of the sampling distribution, but you're going to need to use the sample data to estimate, since we don't know the true parameter. I kind of feel like my explanation in 5 is similar to 6. So I'm just going to kind of leave it at that instead of bogging you down with too much writing. I really just want you to know that the standard error of a statistic is you're using sample data to make a prediction about your standard deviation of a population. Okay? So we need a formula for standard error, right? So I'm trying to keep sound like a broken record. Standard error uses sample data. What's my sample data? Well, the sample data is p hat, not p, because I don't know p, right? So if you're ever asked to calculate the standard error, that's going to be equal to not p, but p hat times 1 minus p hat divided by n. And you take the square root of that whole fraction. So it's the same thing as the standard deviation of the sampling distribution, but sometimes we don't know p. So if you have to use p hat, it's no longer called standard deviation, it's called standard error. And then I was trying to fast forward to number 8. What's the formula for the actual interval? Oh my gosh. So going back, I think it was on skinny page 106 maybe. I said back in the day that it was, in my last tutorial, I said it was the statistic. So let's write this first because I think this helps. It's the statistic plus or minus the margin of error. And the margin of error is your critical value times your standard deviation. Okay? That's your margin of error. So what is my statistic in this case? My statistic is what I get from a sample, and my sample is p hat. And then I'm going to do plus or minus. I always do minus first, actually, because you want to get the lowest number. And then your critical value for proportions is called z star. And we calculate that by doing inverse norm of the percentile. And I think I did that on skinny page 107. 107. So your critical value is z star, and then my standard deviation, or your standard error in this case, because we might not know the standard deviation, is p hat times 1 minus p hat over n, and we take the square root of that. Holy moly. Now this could be hurting your brains because it hurts my brain, but we're going to get in the habit of using this so frequently that it's just going to come naturally for you. All right? So I think our last question